let me walk you through it. Like I said, the working is very simple, but it's about getting over that conceptual hump of, do I understand what this is all talking about? Okay. So, sorry. Let's turn this up. Read the question with me, and I've got to introduce a couple of terms and explain why they're significant. Okay. So, a particle of mass, 3 kilograms. First piece of information. It moves with uniform circular motion, so that gives us a lot of assumptions about the forces and accelerations and velocity that's behaving here. Okay. It's on a smooth table. That word's important. You'll see that come up a lot. It's smooth. What that means is we don't have to worry about friction. That's basically all that means. Smooth table. Speed of 4 meters per second. Okay. And it's attached to a fixed point on the table by a light, inelastic string. Okay, so it's light, meaning that the weight of the string, right? The weight of the string, if it's heavy enough, if I have like a super heavy string, it's going to influence the forces at play, right? So when they say light, that means you don't have to worry about the string and its mass. It's not really going to play into this situation. You can disregard it. It's inelastic. Sorry, so I said light. That means forget about the weight of the string, right? Inelastic, you can tell me what that means. What does that mean? It doesn't get longer, doesn't get shorter, okay? So in other words, you're gonna have a constant radius, and that constant radius is 2 meters. Okay, great. Find the tension in the string. Now, just like with the beginning questions under mechanics, right? F equals ma was where you started for like 95% of the questions, okay? So for uniform circular motion, take that back. For circular motion full stop, right? What makes it circular, what keeps it in a circle, is these equations, right? If the force was any less, the particle would spiral off. It would sort of have this like an elliptical or something like that. If the force was any greater, it would spiral in and it would collide with the object, and it wouldn't be circular anymore, okay? So you can start with this. So here's my starting point. Okay. Now, like we mentioned before, tension is really just this force, right? We're not really going to worry about the direction of it because it's kind of implied. Okay, obviously it's going inwards. Otherwise, it's going to fling off to wherever. Okay. T is a sort of capital T. Because it's pretty obvious that we don't care about the temperature of the objects in this context, T is fine for tension. Okay. And in the same way, because I don't worry about the direction of this is kind of implied, I'm just working out this really. Okay. Now, think back. You have to be careful with, this is kind of death by algebra, right? You have to be careful about what all of your pronumerals are. Omega, how do we define omega? It's angular velocity, right? Now, in this context, because it's uniform, right? We can think back to the fact that, well, omega, right? It's related to linear velocity. In what way? How are they related? Whoops. That linear velocity there, linear maybe, you can see why they have another term for this, right? It really is tangential velocity. It's going around in this curve, okay? And that's why it's an arc, right? And so what you've got is, you've got your theta there, right? And that's changing at a rate of omega. And then you've got your radius, okay? So the change in your arc length, right? That velocity is r omega. Does that make sense? Okay. So what you've got here, instead of omega, I don't want this in terms of omegas, right? I just want to work out the tension, and I've got this velocity instead, right? So instead of an angular velocity, I'm going to sub it out for a linear velocity. The way that I do that is you come down to here, and you say, well, if I've got omegas, but I want to get rid of them, I'll make it the subject here. So this should be V on R. Is that okay? Right? So when you come here, this is going to be MR V on R squared. Is that okay? So in fact, and this line's really important, you can really write this original force, if you want to put the minus sign on it, right? In this case, it's just a tension. But you can use this, another color, as your starting point. You can use this as your starting point. If you don't have things in terms of an angular velocity, right? If you don't have revolutions per minute, but if you have something like this, then why would you have omegas in your starting point, right? You're going to have to get rid of them. So that's an equally valid starting point, right? So from there, once you've gotten to this point, you can just punch in your numbers, right? What's the mass? What do we say? 3 kilos, right? Velocity is 4, so v squared will be 16. And then there's our radius, 2, right? So 3 by 16 is 48, divided by 2, that gives you 24 newtons. That's the tension in the string. That's the force acting toward the center. Okay, so far so good? When we have a look at part B, what's it asking? If the string has a tensile strength of 15 kilograms, okay, mark those words with me. Tensile strength, we'll come back to these in a second. 15 kilograms. Find the greatest angular velocity that the mass can have without the string breaking. Okay, so what you've got here, this tensile strength 15 kilograms, right? What it's telling you is, now it's forgetting about this speed, right? Because the question is now, what speed can I have, right? So we're forgetting about this 4. That means you can forget about this 24, okay? This is what I'm going to have for my tension, right? But because it's 15 kilograms, right? 15 kilograms, really, the tension is 15 times gravity, right? Now, 9.8 is pretty standard. 10 comes up a lot. I don't actually know. I'm just going to leave it as G for now. And we can sub in whatever value that they say. Take gravity be equal 10 meters per second, or whatever. Okay? So 15 G. Now, what am I looking for? What's the question say? I want greatest angular velocity. Yes? So think, do I want to go with this or do I want to go with this? Angular velocity, right? I want omega in there. So I'm just going to say, well, that's m r omega squared. That's all I had to do, right? That's the tension I want, or at least that's the maximum, right? And then I'm just going to solve. I know what mass and radius are, right? 15g, okay? So now I just have to solve for omega. 15g on 6, what's that? 5g on 2? We're not really worrying about the thing changing angular direction, right? It's just going to keep going forward. So therefore, I can just take the positive, the square root of 5g on 2 for positive omega. Okay. So obviously, if you took g as 10, you'd have the square root of 25, or the square root of 24.5 if you used the other value of gravity. Okay. So that's all there is to it. Like I said. Just like F equals ma is your starting point for so many mechanics questions in general, this is the specific kind of F equals ma, either of these, that you get with circular motion. So that's why it's your starting point. As soon as you see that, you're like, bang, that's where I'm going to go. Okay?